the great guy. He talks about a lot of stuff that I don't understand much about, which is cryptography. Passwords. But this presentation should cover a lot of something that is very interesting and very relevant to the conference, the password hashing competition. I don't know if all of you have heard about it, the password hashing competition. Well, he will introduce all this and the different candidates that are part of the competition. So please listen carefully. Shafri?
Thank you. Okay. This will probably be the single most boring talk of the conference. If you want to leave the room, please do it now. I mean, I don't know if you followed what happened with PHC, but I'll present all the candidates. I'll try to minimize the boringness, but let's see how it works. Myself, so it's not very interesting. I will not introduce what are passwords, why we need secure passwords. You all know about this. I will not blame the users. I will not blame the IT sysadmins or the developers who use weak hashes and MD5. Maybe the cryptographers, because if you look at the cryptographic literature, there's not many works about how to secure passwords. Some theoretical stuff, but not really practical research. So the first thing I'll briefly present PHC, and then all the 22 candidates, and finally the next steps. I will not talk about password policies, about password managers, password methods, and so on and so on. Okay, so PHC, I know you know AES maybe. You've probably heard about the SHA-3 competition organized by NIST. CSAR is a brand new competition about authenticated ciphers. So the principle is that people submit ciphers and they try to break the other people's submissions. And at the end, the organizers, they pick the best, well, the one that they deem to be the best. So we have a bunch of people in the panel of PHC. We started this at the end of last year. And I proposed the idea on Twitter, and people were very responsive. Yeah, it's a good idea. Let's do it. Let's do it. So try to have people from both the academic community, like professors, researchers, but also people who crack passwords, people who implement password hashing functions, software engineers. So try to have the right mix of people to make the best choice at the end. You see there's Jeremy Gosney, who is in the other room, Matt Green, Chesnick, well, Sora designer. So many familiar names. Marshrey will be speaking right after me. So we published a call for submission in Q1 2013, and 1 year later received a few submissions. And later this year, probably in October, September, we'll publish finalists. So there will be 5 or 10 algorithms. In 2015, we'll publish the winners. So maybe 1 winner, 2 winners, we don't know. Okay, so there's some URLs. You can go to our website, our wiki, our mailing list, our IRC. So now for the boring part. So 24 minus 2, the good news is that 2 submissions have been withdrawn. So you have only 22 submissions to look at. All right. The requirements has to be secure, it has to be easy to implement, and it has to be easy to understand, because if we want to assess the security or the quality of a submission, we must understand how it works, we must understand how to implement it, and the quality varies from one submission to another. And also we ask submitters to specify at least 2 parameters. Time parameter, so how slow it is, and a memory parameter, how much memory, ROM or RAM, it uses. And an IP statement, so we ask people not to submit anything patented or covered by a patent application and royalty free as well. Okay, so the first guy is called Encrypt. So don't ask me why they choose those names. They have some crazy names, some I'm not able to pronounce, but anyway. So this one comes from Germany, and many times most submissions, as you will see, they do not create everything from scratch. They use some existing function. Some use SHA-2, some use AES for different reasons. I'd say we need a hash function, so let's use an existing hash function instead of creating a new one. So this guy, they use SHA-512. What's very unique, they use floating point arithmetic. It's a bit strange because it's not extremely well defined, so depending on the platform, you may not get the same result if it's not properly specified. So I don't know if they specified it well enough, but that's something that we're looking at. What's been interesting compared to the others, they specify in the algorithm 2 different parts. The part is supposed to bring the cryptographic security, and the one is supposed to bring the computation hardness. Okay, that may facilitate the analysis of the submission, because you try to break it, you may look just at the crypto part, and you want to optimize it, look at the computation part. So I think it's a clear and well-motivated design. So Argon by Dimitri was here, and Alex Bayukov. So they use AES. So the motivation for using AES is that in many of our CPUs, there are native instructions, so dedicated hardware for AES, which makes it very fast on the clients, on the users' servers, CPUs, and so also on the server machines. And this sort of minimizes the advantage of the attackers, because they have GPUs, you don't necessarily have AES NIs in GPUs. So I think that's maybe a good idea. In Argon, you can specify the parallelism, so it's up to 32 times. Stop me if I say something stupid. And I'll just briefly talk about what functions that are really cool compared to what you've seen before. If you look at SHA-1 or MD5, it just takes something and hashes it. There's two new features that password hashing submissions are introducing. It's the first one, server relief. So typically you will send your password and the server will hash the password. But if there is too many passwords, it will take them a lot of time to process everything. So here the idea is to share the workload between the client and the server. So you must specify half of the computation will be done by the client, the second half by the server, or a different ratio. The second one is hash upgrade. So I find the idea very cool because let's say you have a database of password hashes, and you've had this database for years. Now you have new hardware, you have maybe a faster CPU. The attackers, they have faster GPU as well. So you want to upgrade the hashes to something stronger. So instead of asking for password reset for the new password, all the users, you will just take the hashes and upgrade them, transform them to something stronger without knowing the original password. Okay. So I'm going to provide this feature, and compared to other submissions, they have a quite decent security analysis. I don't even have proofs, but bounds of security, theorems, things like this. Yeah. Okay. Botcrypt by Steve Thomas. I don't know if Steve is already there. He's coming from Chicago. He's giving a talk later today. It's, yeah, very different. So they use Blowfish. So Blowfish, the very old cipher that is used in bcrypt. It's well, Steve says that's optimized, well, suited for PHP because PHP has a native Blowfish implementation. And like Argon, it supports server relief and hash upgrade. It's very short, very simple. Catena. So they use Blake2B, function that happen to have design. It's very, very strange algorithm because they use sort of graph theory thing. They prove theorems with respect to those graph structures. So if you're interested in mathematics and graph theory, you may want to look at Catena. And also the same two features, server relief, hash upgrade. And they also have proofs. I put quotes because it was not clear to me what those proofs are proving, but they do prove something at least. All right. Catfish has been withdrawn for IP reason, I guess. So centrifuge is not using AES, not only AES, but AES and SHA-512. It's not AES 128, but AES 256. So AES with keys of 256 bits. Same the benefit of the speed up of AES on CPUs support the NIs. And what's original in centrifuge is that the S box, so the part that brings the cryptographic strength, the nonlinearity, it depends on the password and on the salt. So on the parameters, it's not predefined like in AES where you also use the same S box, the same transformation every time. Here they generate new S boxes for each new password. And they use something that looks like RC4. Okay, so ERORM, what's very original here is that the previous submissions don't give the detail, but they have a memory parameter. So they say how much memory you want to use, 1 kilobyte, 1 megabyte, or even more, but it uses RAM. So the case of EROM is different. They use a big RAM table. So you have to have this huge table in memory prior to starting the hash. So the idea is that if you want to compute the hash password, you need to copy not only the code of the function, but also this huge table that may take gigabytes. So in some cases, it's completely heuristic. In some other use cases, it might make sense. Okay.
That's a static table?
I think yeah, it's static with respect to some parameters. It's pre-computed using a salt or some...
Same for every key, or is it-
yeah, something like this. Doesn't depend on the password. What's also extremely original is that it's not second parameter resistant. What does it mean is that if you're given a hash, you can find another password with the same hash. So they claim that it's not a big problem. I don't know if it's a problem, but it's a bit odd. Gambit, so it uses Ketchak. I don't know if you've heard about Ketchak, but you may have heard about SHA-1 and SHA-2, and Ketchak has been set as SHA-3. They have the same feature, local RAM table, but it's just optional. You may or may not want to use it. And they have what I call a word-to-word transform. I can't recall what it means, but the code is very, very, very compact, very short. LAN area uses Blake again, heavily serial operation. So compared to others, sometimes password hashing function, they try to exploit the parallelism of CPUs. Like in typical laptop CPU, you have parallelism at the instruction level, like SIMD instructions. And you also have different multiple arithmetic units. You may have multiple cores. So some functions try to exploit this. In LAN area, it's completely serial. You have no parallelism at all. And non-uniform sanction timings. And the idea is to mitigate pipelining in hardware architectures. The runner doesn't know what he's doing, but he's the only submission to do this, and it supports hash upgrade. Lyra 2, so it's also one other submission that comes from the academic community, so it's much longer than the other submissions on average. They use Blake 2 in duplex sponge, so you can see as a mix of the function that won SHA-3, which is based on sponge, and Blake, which was another SHA-3 finalist. They have the two-dimensional memory parameters, so they have two ways to use memory, and depending on your platform, you may want to favor one type of memory usage against the other. But they take a password, take a salt, and something that they call Basil. So it's a personalization string. So the motivation, well, what they claim is that if you are maybe different customers, different machines, different systems, you may use different personalization strings to have a different function. If you give the same password and same salt to different systems, they will compute a different hash. And they have quite nice security analysis as well. So this one has been withdrawn. The lesson here is that if you publish some cryptographic design, make sure with your company lawyers that you're allowed to do it. Yeah. Makwa, so Thomas is here. That's maybe the most original submission because it's using big number arithmetic. So the same kind of operations that you see in RSA or Diffie-Hellman numbers. It uses the HMAC-based pseudo-random generator, and it supports something called delegation to untrusted system. So here the idea is that you will delegate part of the computation to one system, but you will not need to trust this other system. And I'm not giving the details because it's not that easy to explain. But yeah, you might want to look at the Makwa specification. It's what password escrow. I don't really remember what password escrow is doing. Maybe you can explain this briefly.
Okay. If you're doing computation modulo big RSA modulus, and if you know the factor, you can reverse things. So you have a shortcut, or you can even recover the password. If you don't skip the password, you just got that. You can skip hash, and you can skip the delegation and so on. But you have a possible secret to get some extra power.
Do you want to say it again on the microphone?
Okay. Yeah. Thank you.
Sorry.
So there will be a long talk by myself, if you can tolerate my French accent, tomorrow for 1 hour. And I'll explain that at length. But basically, you are doing all computation modulo a composite integer, like an RSA modulus. And if you keep knowledge of the factors of that modulus, it gives you a few extra powers, such as computing a shortcut, a fast pass for computation, or even recovering the password from the hash. So really, if you keep knowledge of the factors, it's no longer a hashed encryption, and it's some sort of extended Rabin encryption.
You can see like a trapdoor password hashing function. Yeah. Okay. The next one is MCS PHS, Mr. Maslenikov. It's very strange because it uses a function called MCS SHA-8, because prior to that there was MCS SHA-7, MCS SHA-6, MCS SHA-5, 4, 3, 2, 1, which have all been broken. So this one seems to be more secure than the previous ones. And they use, so that's a bit odd to me, but probably that may make sense, I don't know. But to build this new password hashing function, they use another password hashing function, which is PVKDF2. and it's extremely simple. Yeah. So Omega Crypt, so it doesn't use AES or SHA, but Cha-Cha and CubeHash. So something that's extremely fast on typical CPU because it's exploits the SIMD operations. It makes 4 to 8 addition or XOR simultaneously, so you can directly use the SIMD operations to do this. What's maybe good or not so good depending on the context is that it's doing data-dependent branchings. So it means that there might be timing leaks depending on the system where you're running the function. I think it depends on the password. So depending on the password you give, you will make different branchings, so you will execute different code, and the execution time may vary. Okay. But they claim that they have a timing attack mitigation. Okay. Parallels, second submission by Steve, it is SHA-2512, and it has 2 different parameters for the time. I think that's an interesting idea. One time parameter is with respect to sequential operation, and the other with respect to parallel operations. So if you have a parallel architecture, maybe you will use the parallel parameter. If you are completely serial, you will just do the serial operation. And it uses constant low memory, so it's not a high memory password hashing scheme. There are some cases where you have very few RAM, so maybe that makes sense. That's very, very small. You see the code is there. So very easy to implement. Just small interruption. There was some guy on the forum say, yeah, I don't know how he called it. It's like putting lipstick on pigs. That's can go wrong. Well, he wasn't happy with PHC. I think his point was that instead of attempting to solve this problem, we should work on something that would replace password. So there's a whole bunch of ideas like, biometrics, and people say, don't use passwords, it's insecure. I think his point was, we should just client certificates. So, well, yeah, in an ideal world, we should all have client certificates, but in terms of usability, not really sure. Yeah. You always need password, so. This one is poly pass hash, so poly for polynomials. Polynomials are polynomials in AES, not really in SHA-2, but SSS means Shamir secret sharing. So it's a secret sharing scheme by Ali Shamir and others. And I have to admit I've not completely understood what these guys are doing, but it's completely crazy. And it has some very strange properties when you have many users. So I think as a panel member, we'll have to take time to understand what it does. Because I think it's the kind of submission that in many cases makes no sense, but in some niche use cases is really a good idea. Well. So Pomelo by Hongjun Wu. The alternative here is that it uses no external primitive, so it's complete standalone submission. There's sort of feedback shift register, so something extremely simple that we used to see in cryptography. It claims to have mitigation of cache timing attacks, and implementations are really simple. So in terms of Parzen, I can't recall what it's doing, but Hongjun has a good experience in designing crypto primitives, so I will trust him in with respect to cryptographic security. So pufferfish. So Jeremy is not in the room, so okay, I can say bad things about pufferfish. No. Jeremy is an independent member. He is a panel member too. No, it's using Blowfish. I think it's interesting because he modified Blowfish to have again password dependent as boxes. So we've seen something in our submission, and it tried to improve Bcrypt and to make it more suitable to modern architecture. So he made it 64-bit. So Bcrypt by default has a fixed 4K amount of memory. So he modified Bcrypt to have variable memory. And he already wrote patches for John the Ripper. So I think that's interesting submission too. Rig, which is Blake, they use a bit reversal permutation. So here the idea is that you compute a large array of bytes, and when you're done, you invert all the bits. So the idea is that it forces you to remember all the bits because the first one will become the last one, and so on and so on. Okay. So they claim that it raises cache timing attacks, and also the same 2 features that we've seen before. So just to also submission, we're almost done. So I have no clue how to pronounce this. Again, they use no external primitive. It's a very strange submission, very intriguing. And he separates slow and big computation. So then maybe easier to analyze because One part is respect to speed, the other one is respect to memory, and they have another parameter for being more slow. So I still have to understand what it's doing. But the Tortuga, that's a cool story because he said, yeah, I use Turtle from Matt Blaze, this famous cryptographer. So I never heard about Turtle. So I've been studying crypto since 2004 or 5. I never heard about Turtle. And it's a very strange cipher. You should look at the paper. It's something completely crazy. Matt Blaze, he was shocked that someone uses his design. I mean, this guy's out of his mind. I don't know. The key spawn structure. So like SHA-3, but with a key. I say it's simple because it looks simple, but maybe less simple than it looks. So 2 cats by Bill Cox. I think it's the penultimate submission. It uses Blake to S, Blake to B, SHA-256, SHA-512. So these are all for guys to implement 2 cats. And originally it uses integer multiplication, which is very fast on our CPUs and maybe not as so fast on other platforms. There's a tweakable thread and instruction level parallelism. So like I said, if you have multi-threading, SMD instructions, you may take advantage of those with 2 cats. And again, the same 2 features. So that's the cats of Bill. Didn't find a picture to put. So Jan, AES and Blake 2, parallelism parameterizable like in most emissions. And here the strange thing is 3-time parameter for distinct sources. So I don't remember the details, but maybe 1-time parameter is for addition, maybe another type parameter is for multiplication. That's the idea. It's very small, very compact. And the last one, we're almost done. So yes script by Solar Designer. Nobody is there. Okay. So you may know script, maybe the state-of-the-art password hashing scheme, which has some very nice property and a few not so nice property. So Alex, he tried to improve it, to modify the script, to have a local ROM like we've seen before in, I don't recall the name. And he modifies SASA20, which is in script, with something that, according to his analysis, is slightly better. There's different parallelism option and supports server relief. So one might see it as something very sophisticated, very complicated, but on the other hand, it offers many options, many flexibility. That's not completely finished. The last part is well, what's going next, what the future, and how you contribute if you're interested. So like I said, we'll select the finalists soon. We started discussing with the panel how to vote, how to make this in a sort of rigorous way. And then we'll select the winners next year. We expect that they will become de facto standard because, well, nobody's really happy with the current state of the art as script, bcrypt, bkdf2, but we may or may not want to try to push the winners in some formal standard on our ISO, IETF, or NIST. We have some NIST people in the panel members, so they may help. One question I've been asked is, what about conflict of interest? Because some submitters are in the panel of PHC. So we discussed this, and what we'll do is that the people who submitted something in the panel, they will not be allowed to vote formally. So this has been accepted by all the panel members. What's the evaluation criteria is for security, in terms of cryptographic security, efficiency ratio, so how fast it's on a GPU on the attacker's device compared to the defender's device, and simplicity. We don't want something that takes weeks or months to implement, or that has too many dependencies. We want something to be as simple as possible. And we also look at extra functionalities, what I mentioned, hash upgrade, server relief, and the target application. So one submission may be really bad, I know, for scripting languages, but very good for native applications, and the other way around. Okay, so transparency, we have some private discussion, obviously, with the panel to decide who we will select. We'll see whether we publish our discussions later, but generally we try to be as transparent as possible to have most of the discussions public. We have this public mailing list, and a lot of the panel members are active on the mailing list. So if you want to get an idea of what people are thinking, you can register to the mailing list. And when we're done, we'll publish a final report to justify our choices, why we chose this one, and also why we did not choose the one we did not choose. So we need people to review the implementations that have been published, to write third-party implementation, because maybe the submitter is the only one to have implemented this function. We need independent implementation based on the specs. And we also need people to try to break the submissions, be it with respect to cryptographic security, side channel leakages, and so on. Okay, so I think I'm done. Hope it was not too boring. Please look at the wiki, the website, or email me if you're interested. Thank you.
Well, just